Hey guys, Steve here with 6 Star Automotive. Welcome back. Before we get started though, please like, subscribe, and follow me as we talk about brake fluid. So brake fluid has always been one of the more fascinating fluids for me, given its importance and its attributes. Unlike the other fluids we're talking about in this series, brake fluid is the only one that's hygroscopic. That means that it absorbs moisture. It actually is so hygroscopic that it absorbs moisture out of the air, which is one of the reasons why you'll hear that you really shouldn't use brake fluid unless it's out of a sealed container. We'll get to why that's important here in a little bit, but first let's talk about the types of brake fluid that there are. There are generally 3 different types of brake fluid. You have DOT or DOT3, you have DOT4, and DOT5. DOT standing for Department of Transportation. So these fluids are standardized. The main differences between the 3 are their performance characteristics. So DOT3 brake fluid is a polyethylene glycol-based fluid. One of the more important attributes is its resistance to boiling. In its purest form, it'll boil at about 400 degrees Fahrenheit, which is great. But like I was saying before, if the fluid has water in it, which it's hygroscopic, so eventually it's going to have water in it, it can actually lower the boiling point to about 280 degrees Fahrenheit. We don't really want that because brakes can actually get up to about the 200 degrees Fahrenheit in normal operation. DOT4 brake fluid is usually used in European or performance-based cars. It has a base of polyglycol esters, among a lot of other things, and it has a boiling point of about 440 degrees. It can go down to as low as about 310 degrees if it has too much water in it, which as you can see is actually much better than the DOT3, but obviously just like with anything, the higher you go in performance, the more cost you're going to end up having. So one important thing to consider is that you can technically mix DOT4 and DOT3 brake fluids together, but only under very specific circumstances. If a vehicle has DOT3 and is designed for DOT3, you can put DOT4 in it, but you don't want to go the other way around. So it's always best to just do what it says in the bottle, do what the manufacturer recommends, and you'll be fine. The third fluid is the least common in vehicles nowadays. You're going to see it in postal vehicles, and they still do it in some motorcycles as long as they don't have ABS. We'll get there in just a second. So DOT5 is a silicone-based fluid. It has a boiling point of between 350 and 500 degrees, depending on its condition. The reason that you don't see DOT5 fluid in most vehicles is because of a couple of things. The silicone-based fluid is not compatible with a lot of different types of rubber. So in ABS systems, you have a lot of rubber seals, a lot of rubber O-rings. In the modulator valve, the brake hoses, the brake lines obviously. Another downside of using DOT5 fluid is that it has a higher tendency to foam under rapid pressure changes like what is experienced in ABS systems. So we don't use those. Even though it's better for the boiling point, it has too many downsides to be really practical for most applications. One interesting thing to note is that pretty much all brake fluids have the same freeze protection. You're looking at about negative 40 degrees Fahrenheit. Side note, something I actually learned while making this video, negative 40 degrees Fahrenheit is equal to negative 40 degrees Celsius. Check it out. So the reason that it's so important that we understand that brake fluid is hygroscopic is that that water in the fluid will actually mix with the chemicals that are inside the brake fluid and create an acid. And that acid in the brake system will actually start to eat away at some of the metal components. So let's get to the reason why we do want to replace the brake fluid. Again, the commonality with this whole series, it's all about the additives. I guess I should probably change the name of the series. The most important additives in brake fluid are just like some in the others, corrosion inhibitors, pH buffers, anti-foaming agents. So we'll get back to that in a second. How do we know when brake fluid needs to be replaced? So there's a couple of different testing methods. You have conductance testing. You'll see actually those little 2-prong electric testers that are really just testing for water in the fluid. The problem that I've had with those is that many brake fluids actually have conductive additives in them, which will make them fail right out of the bottle. So it's not an extremely accurate test. The type of test that we prefer uses these brake fluid test strips. They actually test for copper in the brake fluid. I'll tell you why in just a second. They are substantially more expensive than the previous method we talked about, but much more accurate. The last thing to consider when it comes to making recommendations on brake fluid services is simply the interval. Brake fluid being hygroscopic, it's going to absorb moisture constantly. So it's generally good practice to replace a brake fluid every 2 years. Some might say that that's overkill, but I'm not telling you have to, right? That's one thing that we're very adamant here about, is that I'm not trying to scam you, I'm not trying to sell you something you don't need, I'm not trying to do anything like that. I do what I do in love, not in any spirit of greed. I just want you to know what I think you should do in order to keep your car lasting as long as possible. That is purely the motivation. In order to prevent larger repairs, calipers, master cylinders, modulator valves, we think it's best to at least give you the option of changing that fluid out more regularly so that hopefully we can prevent those types of situations from happening. So why is there copper in your brake fluid? Let's see. So this is a standard brake system. So you have your master cylinder here, you have your modulator valve here with your ABS and your ABS pump, and then these are all those brake lines I'm talking about. So you're gonna have a brake line for each individual corner. Each individual wheel is gonna have its own brake line in most systems. All these brake lines are actually made out of a single piece of steel that is rolled over and welded. In order to make them seamless, they actually will coat the inside of the brake lines with copper. As the fluid becomes acidic, it starts to eat away at the majority of the surface area in the system, which is the brake line. So then the copper in that inner wall of the brake line starts to degrade first, which puts copper in the fluid and then lets us determine how much is actually in there to see how acidic the fluid is. As you can see, a lot of components here actually connected to the hydraulic system, right? We have the calipers, which are made out of iron, and then again, your modulator valve and your master cylinder, which is made out of generally aluminum. You know, do you want to do the service sooner rather than later? It really just kind of depends on what you want for your vehicle. Another thing that I see that some people don't fully understand is brake fluid level and top-offs. So your brake fluid is going to have a maximum and a minimum mark, and that isn't like a lot of other fluids in the vehicle where it actually fluctuates and you just top it off because it uses it or it evaporates or something like that. That's not how this system works. It's actually more of a gauge as to the brake pad thickness and the shoe thickness. So I've got a video here that actually can kind of put this into better perspective. As the brake pads wear down, that space is actually taken up by the pistons that are inside the caliper. So the piston is going to push in, which is going to then fill the caliper with more brake fluid and then lower the brake fluid level in the master cylinder. If it's just a little low, right, if it's between the minimum and maximum, you don't want to really mess with it. If it goes below the minimum, then you could either really need brakes or you could have a leak. There's actually a sensor inside of your master cylinder that will turn on your brake light. Basically, point being, don't top off your brake fluid unless it's below the minimum mark. And then if you need to, come and let us know as soon as possible. So in vehicles that haven't had their brake fluid exchanged in a long period of time, you'll actually start to see kind of a black or a gray sludge buildup inside the master cylinder. I believe this is actually caused by the rubber brake lines in the system deteriorating over time and actually leaking dye and rubber into the brake fluid, which then obviously makes its way up to the top of the master cylinder. Not something I think you should be extremely concerned about, but it shouldn't be there, so it's just another reason why you should do a brake flush. So there actually is one more thing, and I just saw this down on my little shelf of goodies down here. There's a brake junction in the back of many Subarus that tends to corrode out. I think it's because the wheel kicking around the salt and the slush, and it pushes it directly into where this brake junction sits, and then it just corrodes it out, which is why I recommend car washes in the wintertime. 95 Express car wash is one that we recommend all day long. I have them for my vehicles. I have them for the shuttle car, for my wife's car. Brandon has it for his car. So we were trying to combat stuff like this. Sidebar. But what it does is it actually will corrode the brake line from the outside in, and we've had multiple instances where they've just failed flat out. You hit the brake pedal and then it just bursts. I'm not trying to scare you or anything, but I mean, this is relatively serious. So we made a point to add this to our brake inspection so that we catch it on as many vehicles as possible. I actually developed a service to kind of help combat this problem, using a process of cleaning off the surface rust and then putting a wax coating in. It's been pretty effective so far. Worst case scenario though, we do stock the components to replace this. We'll actually graft in a new section of brake line that's deteriorated and put the junction back in there. So that's all I have for this video. Thanks for watching, guys. If you have any questions, please give me a comment down below. Again, like and subscribe, and give us a call if you want to experience the 6-star difference for yourself. That's going to be fun in the editing process. So we'll get back to that in a second.